Continuing on with our unit in exponents, we look at some problems that are written in test type questions. For example, a griddable answer choice. So the question is 3 to the negative n is equal to 1 over 81. What is the value of 3 to the n? With negative exponents, all you're doing is taking that term and putting it under 1. That means it's really 1 over 3 to the n, and it gives us a form that is similar to that in 1 over 81. We can assume that 1 is equal to 1, and 3 to the n is going to be equal to 81. 81. And we just bubble 81, correctly pick the 8 and the 1 bubble, color those in, and leave the rest blank. Here, number 2, which expression is equivalent to this? What we do is do the numerator first. 3 times 2 is going to be 6. X to the 7th times x is x to the 8th. I just added the exponents because the base was the same. I can do that. 7 plus 1 is 8. Now the bottom, just leave it alone for now, and then we'll go to the next step. We simplify. 6 divided by 6 is 1. We don't have to write 1. X to the 8th divided by x to the 4th is x to the 8 minus 4, and 8 minus 4 is 4. Should be x to the 4th, and we look in the answer choices. That answer is H. The next one, I'm just going to go straight to the question. Which expression is equivalent to 3 times 10 to the 4th times 5 times 10 squared? Now, with multiplication problems, the order is not important. We can just go ahead and do 3 times 5 in the beginning, and we get 15. The answer choices that have 15 are A and B. Eliminate D and C then. Now, 10 to the 4th and 10 squared, when I multiply those, I should keep the base because it's the same base. I can just add the exponents. 10 stays the same. 4 plus 2 is 6. I'm looking for 10 to the 6th power. Between A and B, B is the correct one because it has 10 to the 6th power. Further along with the multiple choice questions, Jeremy reasons that this expression right here equals this expression if A is not equal to 0. Which statement supports this reasoning? If you look at the answer choice, they just give us different rules for exponents. The rule that's most used here, or most applicable to this situation, is 0 power. Whatever this term is, it's raised to the 0 power, it just becomes 1. And that means anything over 1 is just the same as that term. Whatever that term was, we divide by 1, nothing changes, so the top term doesn't change. And this answer shows that right here. And we look at our answer choices, we're looking for the answer that shows the rule with 0 power, and the only one that applies is F. Number 7. Which statement describes the relationship in the last 2 rows of the table? If we just skip to the last 2 rows, they're dealing with negative exponents. We just look at the answer choices, look for the one that explains negative exponents, and that is D. Number 5, which expression is equal to 4 to the negative third? With negative exponents, just take the whole term and write it as the positive version, 4 to the third, and put that underneath 1. And we know 4 to the third is 4 times 4 times 4, and that is 64. And we still have that 1 on top, 1 over 64. C. Now, the next one, it gives us a situation, and we want to find values for x and y that prove this situation is wrong. Let's try the first one with F. X is 2, that means wherever x is, I'll put 2, and y is 0. Wherever y is, I'll put 0. Now, all my x's and y's are filled with numbers. They're replaced with numbers, and now I can evaluate this and see if it is true or not. 2 squared is 4. 2 to the 0 power is just 1. And 2 to the 2 times 0 is the same thing as 2 to the 0. And 2 to the 0 is 1. 4 times 1 is 4. 4 is not equal to 1. That is not true. And that is what the question asks us. It wants us to find answer choices that prove it is wrong. And F fits that situation. Now, jumping to polynomials, distributing. Let's start with the basic example, just distributing a number. That negative 3 is distributed twice. Negative 3 times 8, negative 24. And there's an x there, I leave the x. And negative 3 times positive 5 is negative 15. Okay, number 2. It looks complex, a lot of numbers, a lot of exponents. Just take it one step at a time. Do the numbers first, 2 and 3. 2 times 3 is 6. Now the b's, b to the 6 times b to the negative 1. I just add the exponent. 6 plus negative 1 is 5. And all of this, 6b to the 5th, I am going to square it. With this, I have to square the 6, and I get 36, because 6 times 6 is 36. And I square the b to the 5th. That is the same thing as multiplying 5 times 2, I get 10. It will be b to the 10. 36b to the 10. Over here, number 3. What I'm distributing now is 11a. It's being distributed twice. 11a times 2a is 11 times 2, 22. a times a squared. 11a times 7 is just 11 times 7 first. That is positive 77, and I still have that a I must write next to 77. Final answer, 22a squared plus 77a. Number 4, I'm distributing this x to this term, only this term right now. It's really multiply all the way through, but I'm just going to do it one at a time, starting from left to right. When I do that, I get 3x to the 6, because there's a 1 here. It's not written, but I know it's there. I add 1 and 5, I get 6. Now this term I'm going to multiply with the one I did not use yet, 2y to the 0. And I know y to the 0 is just 1, and 1 times 2 is 2. That's how I got 2 here, because 0 power is just 1. And then when I multiply these two, I get 2 times 3 is 6, and I still have the x to the 6 left. Final answer, 6x to the 6. Let's jump to number 6. I'm going to distribute the 5y all the way through this trinomial to all three terms. 5y times y squared is 5y cubed, because 1 plus 2 is 3. And then the next answer I know is going to be negative. 5y times 3y is 15y squared. I add 1 and 1. The last would be 5y times 6, that is 30y. Final answer, 5y cubed minus 15y squared plus 30y. Number 7, two variables being distributed here, a and b, and it's a negative. That means all the signs of these inner terms will be changed to negative. There's a negative there, I just rewrote it. Negative ab times 3b squared, that's going to be negative 3a, nothing happened to the a, but the b is going to change the exponent to 1 plus 2 is 3. And continuing on, the next term is going to be negative as well. A times a squared, but there's a 4 in front, I must include that 4. 4 first, then a squared, and then the b times b is b squared. And last term, negative times a negative will be a positive, and then the coefficient or the number in front of the variable or variables is 6, and then a times a squared is a cubed, because 1 plus 2 is 3. I add the exponents. And now the b, there's no b term, or b here. There's no b here. I just keep that first b from this part and leave it. Final answer, negative 3ab cubed plus minus 4a squared b squared plus 6a cubed b. One thing to do with these long distribution problems is, if keeping track of all the exponents and the variables is difficult at first, just go ahead and write the term you're distributing, in this case 4m squared, 3 times, or however many times you're distributing that term, write it that many times. 4m squared, another 4m squared, and be sure to put some space in between your terms so you can fill in the blanks. Now this is being multiplied by the first term inside the parentheses, 9m squared n, and then positive, I write plus, because positive here, it just stays the same as positive. And then I write the second term inside the parentheses, mn, next to this 4m squared. And then last, positive times a negative would be a negative. And the last term in the parentheses is 5n squared. I didn't say negative 5n squared because I already counted for the negative sign right here. I just go ahead and write 5n squared right there. And then from here, just go ahead and follow the rules of exponents and multiply the same variables, and at the end clean it up and you'll get your answer. Now, an example of cleaning up your problem is, after distributing, in this case I get 3a squared plus 2a plus 8a minus 32. I can combine the like terms. I look for the same variable and same exponent. There's only one a squared term, and that's the beginning one. I leave that alone. I can't combine it with anything. The next two terms are like terms because they have same variable and same exponent, a to the first, a to the first. 2a and 8a give you a total of 10a. And the last term, negative 32, that stands by itself, can't be combined. And there's my answer, 3a squared plus 10a minus 32.